Assalamualaikum and good morning everyone. In this lesson, we're going to talk about probability. The first thing we need to do is to go through a bunch of definition because statistics have a lot to do on how they name and define certain things. So let's start with a very simple one, what we mean by probability and why we need to learn about probability. Life is full of possibilities and taking chances every step of the way. Chances of being successful, ups and downs, as simple as chances of the day to be sunny or rainy. So, what is probability? A chance for a certain outcome or a certain event to occur. If the probability is high, it is very likely for an event to occur. Otherwise, if the probability is low, it is unlikely for the event to occur. A probability provides a quantitative description of the chances or likelihood associated with various outcomes. It provides a bridge between descriptive and inferential statistics. Now, before we go over some examples that talk about how to calculate probability, we need to talk about something called sample space. So, what is sample space? The sample space is basically the set of all possible outcomes that can occur. It is denoted by the symbol capital letter S. Each outcome is in a sample space is called an element or a member of the sample space or simply a sample point. For example, let's say we have a sample space S and the element inside is A, B, C and D. This is called the element or the member of the sample space. So, we can also call A belongs to S, or we can also say E does not belong to S because E is not in the sample space of S. So, a set can be defined in two ways. First, simply list the element, like this one. And secondly, by describing the properties by the members or a non-members. Okay? So, in this example, let's say here we flip a coin. What are the possible outcomes or the likelihood event of flipping one coin? There's only two possibilities you can either get. It's either heads, H, or tails. Okay? Now, what if you wanted to flip, let's say, two coins? What are the possible outcomes? What is the sample space for flipping two coins? We'll see in the next example how to create something known as tree diagram. Next, we consider the experiment of tossing a dice. The element of the sample for the number that shows on the top face is 1, 2, 3, 4, 5 and 6. What are the chances or probabilities we can get 1 or 2 or 3? That's what we mean about what is likely or unlikely outcome. This is an example of listing all the elements of a sample space. Secondly, if you're interested to see the even or odd number on the top face, the sample space is even and odd. Here is the description of the properties held by the members. Example 2.3, 3 traffic lights are selected randomly. each product is examined and classified defective D or non-defective N. The question is to list the elements of the sample space. So to help us get the answer, we're going to create a tree diagram. The first traffic light, we have two possibilities, D and N. Okay. Now let's say if we get D for the first one, then for the second event, we get another two possibilities, D and N. Likewise, if we get an N during the first traffic light here, on the second event, we can also get D and N chances. Okay, so then the same process for the third one. So every D and every N, we get also the possibilities of D and N again. Okay, so notice that we have the possible outcomes. So the sample space is going to be the first one. The first outcome would be D, D, D. So the second outcome would be D, D, N. And then the third one would be D and D. And the fourth one would be D and N. And so on. For the non-defective would be the fifth outcome. So N, D, D. And then N, D, N would be the sixth. And N, D, 7. And the last one, the eighth outcome would be N, N, N. Okay. So this would be the sample space of 3 traffic lights selected randomly. Here is the next definition. What is an event? An event is a subset of a sample space. Remember that sample space is all the possible outcomes, so an event is a subset of that. Example 2.4. Specifically on tossing a dice, list down every number on the dice. One, 2, 3, 4, 5, and 6. An event could be tossing a dice and looking for the number shows on the top face of a dice which is greater than 3. So an event is A. So the sample space for an event A is a subset of S which are 4, 5, and 6. Then to calculate the probability of an event current, it's equal to number of favorable outcomes or outcomes that lead to an event and current divided by the total possible of number of outcomes. So here the P event PA would be 1, 2, 3 number of event 3 over the total of the sample space would be 6. So it would be 1 over 2. So it's a 50-50 chances for the event to occur. Next, we have a case of 3 traffic lights selected randomly again. So each product is examined and classified defective D or non-defective N. So list out the event as B that at least 2 traffic lights are defective. Okay, so we identify and look for an event that at least 2 traffic lights are defective. So we have 1, 2, 3, 4. So we look at the sample space that has minimum 2D. So we have B as an event. It's a subset to the sample space with 4 outcomes. Okay, so PB would be 4 out of 8 equals to 1 out of 2 equals to also 50-50 chances for the event to occur. Now, we've come to define some of very important terms in probability. These terms are complement, intersection, mutually exclusive events, and union. They're all part of the set of what we call Venn diagram. Venn diagrams are used to illustrate graphically what set, sample space, intersection, and union are to make it easier to comprehend. So, what is complement? The complement of a set or subset is simply all the elements which does not belong to the set or subset. It is denoted by a symbol of a set with a prime. From previous example of 3 traffic lights selected randomly, the complement of event B is simply the element which does not belong to the subset. So, let's draw a Venn diagram here. We have a sample space S, and then inside the subset of S we have an event B, and the complement of event B is B prime, is the element which does not belong to B. So next we have intersection. The definition of intersection is only those elements that common to both subsets. Suppose that we have a subset A and B in a sample space. Here we can assume that the sample space S contains all the numbers from 1 to 10. So here S equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. And A is the subset for the odd number. A 1, 3, 5, 7, 9. And then B, we have the element of number from 1 to 5. So, the intersection are the 3 numbers which are common to both, denoted by A intersection of B, which is 1, 3, and 5 here. So, inside we have 1, 3, and 5. Next example is using descriptive properties held by the members, which is, in this case, we have a sample space of students from Faculty of Engineering. Event C is the student selected randomly from Department of Civil Engineering, and event F is for the student is a female. Then C intersection with F is the event of all female students from the Department of Civil Engineering. So if we draw here, we have a sample space S for all the students in Faculty of Engineering, and then we have C, students selected randomly from Department of Civil Engineering. Then we have a female student from the Faculty of Engineering, and the intersection of that two events is a female student from Departments of Civil Engineering. Let's take a look at the example of tossing a dice. Let A be the event that number that shows on the top face of a dice is not greater than 4. Let B the event that the number is odd. Okay, so hence A intersection with B is 1 and 3. Okay, if try to draw, have sample space, and then we have A intersection with B, and inside here is 1 and 3. Next, we have mutually exclusive events, which is also called disjoint, where two events have nothing in common. So we toss the dice again. Event A which has elements number of not greater than 4, and then C has element that greater than 4. So if we can see here, A and B has no element in common. Okay, if we draw a Venn diagram with a sample space of all numbers on a dice, so we have event A with number 1, 2, 3, 4 inside, and then we have event C with 5 and 6. So there's no element in common for both events. Next, we have union. The union are the complete set of all the elements that belongs to A and B. So again, we use the same event A and C from previous example. So let's try to draw here a sample space with event A, and then we have event C. So the union of event A and C is gonna be all the elements inside the sample space in this case. Okay, now let's see example 2.11, and the experiment consists of tossing a die and then flip a coin once if the number is even, and then if the number is odd, you flip the coin twice, and then using the notation for H to denote the outcome that die comes up for first, and then heads, then 3HT is dice come up 3 followed by head and then tail. So construct a tree diagram to show the 18 element of the sample space, and then list the element corresponding to the event A. A number less than 3 occurs on the die, and then event B, 2 tails occur, and the element of A prime, and then A prime intersection with B, and then A union with B. Okay. Alright, let's construct a tree diagram first. So list all the numbers that we have on the die. Okay, and then for even number you have to flip the coin once. Okay, and then for odd number you have to flip the coin twice. Okay, so to write a sample space S, so you have 1 H, 1 HT, so it's going to be 1 H, 1 HT, so 1 TH, 1 TT. Alright. T. And then you have 2H, 2T. Okay, so that's 18 elements of the sample space. And then we have A, event A, which the numbers on the die is less than 3, so and then event B is when the tails come up twice. And then the elements other than A is those two lines. Okay, so A prime intersection with B. So you have to find so those elements in commons we have 3tt, 5tt. So A prime intersection with B is 3tt and 5tt. Okay, and then the final question is A union with B. So for A union with B is the combination of these two events. Okay. Alright, here is the exercise for you to practice. So we've come to the end of part 1. Until next video, thank you for watching.